Today's lesson, acids and bases according to Lewis concept. In this lesson, the points to be discussed are a short biography on scientist Lewis, Lewis acids, Lewis bases, and some chemical reactions in which Lewis acids and bases show their acidic and basic properties respectively. So let's begin. The first point is a short biography on scientist Lewis. The full name of scientist Lewis was Gilbert Newton Lewis. He was an American physical chemist. He was born on 25th October in 1975 in Massachusetts of USA. He died on 23rd March in 1946 in California of USA. Lifespan was 71 years approximately. He was known for electronic theory of acids and bases. Let's see the next point. Now the point is Lewis acids. Let's see which compounds are Lewis acids. Here, carbon dioxide is a kind of Lewis acid, sulfur dioxide, sulfur trioxide, boron trifluoride, aluminum chloride, copper 2+, etc. are Lewis acids. Now let's see the characteristics of these compounds, that means Lewis acids. First of all, carbon dioxide. This is the structure formula of carbon dioxide. Here, electronegativity of oxygen is 3.5 and carbon is 2.5, oxygen 3.5. The electronegativity difference between carbon and oxygen is quite high. That is why these covalently bonded electrons move towards oxygen. Here, towards oxygen. As a result, a positive environment is created over carbon. So, carbon dioxide has a attraction tendency towards electrons. That means carbon dioxide is a kind of electrophilic substance. In other words, we can say carbon dioxide can accept one pair of electrons. Now let's see another compound, that is sulfur dioxide. The same structure formula of sulfur dioxide. Oxygen's electronegativity is 3.5, sulfur 2.5. So covalently bonded electrons move towards oxygen, here also towards oxygen. As a result, around sulfur there is created a positive environment. So sulfur dioxide is a kind of electrophilic substance as well. That means sulfur dioxide can accept one pair of electrons during chemical reaction. Let's see another compound, that is sulfur trioxide. This is the structure formula of sulfur trioxide. Here, electronegativity of oxygen is very high compared to sulfur. That is why covalently bonded electrons move towards oxygen, and as a result, around sulfur there is originated a positive environment. That means sulfur trioxide is a kind of electrophilic substance as well. That means it can also accept one pair of electrons. Let's see another compound, that is boron trifluoride. This is boron trifluoride. Boron trifluoride is a kind of covalent compound. This is covalent bond, this is covalent bond, this is covalent bond. So around boron, in the outermost shell of boron, in boron trifluoride, there are 6 electrons, which is not octet fulfilled. So it has desire to accept another pair of electrons. So boron trifluoride can accept one pair of electrons. Let's see another compound, that is aluminum chloride. This is aluminum chloride, which is a kind of covalent compound. These bonds are covalent bonds. So around aluminum there are 6 electrons. This is also octet not fulfilled. So it has desire to accept another pair of electrons. So we can say that aluminum chloride is a kind of electrophilic substance as well, like boron trifluoride. Let's see another ion, that is copper 2+. Copper 2+ is a kind of ion that can accept 4 pair of electrons. So all the compounds we see here have tendency to accept electron pairs. Now we can say that Lewis acids are the compounds that can accept electron pairs. Simply, Lewis acids are electron pair acceptors. That means here acid acceptors. There is a rhythm here. That means Lewis acid electron pair acceptors. Acids acceptors. This is the rhythm. Acids acceptors. That means electron pair acceptors. Now let's see which compounds are Lewis bases. Now the point is Lewis bases. Which compounds are Lewis bases? Here ammonia, water, hydroxide ion, cyanide ion, chloride ion, etc. are Lewis bases. Now let's see the characteristic properties of Lewis bases. First of all, ammonia. This is structure formula of ammonia, in which over nitrogen there is a pair of electrons. That means lone pair of electrons, or simply free pair of electrons, or we can say that in ammonia there is excess of electrons. In ammonia there is a plenty of electrons. So ammonia can donate these one pair of electrons to acids, Lewis acids. That means the Lewis acids are electron pair acceptors. So ammonia is a kind of Lewis base, that means electron pair donor. So Lewis base, electron pair donor, and Lewis acids are electron pair acceptors. Now let's see another compound, that is water. In water, over oxygen there are 2 lone pair of electrons. This is also with excess electrons. That means water can donate one pair of electrons towards Lewis acids. Let's see another compound, hydroxide ion. This is hydroxide ion. This is 1 minus charge. Here there are 2 electrons. Let's see here, that is, suppose this is sodium hydroxide. When it is dissolved in water, then sodium plus and hydroxide minus will be formed. So here this minus is for 1 electron that came from sodium, but here actually there are two electrons in this way, that is hydrogen, here oxygen, two lone pair of electrons, and another electron which is of oxygen itself. Another electron came from sodium. So for this electron, this minus charge is put here. So in this minus charge, actually there are one pair of electrons. So hydroxide ion is a kind of ion or Lewis base that can donate one pair of electrons. Let's see another one, that is cyanide ion. The structure formula of cyanide ion is this. Here there is one pair of electrons. Cyanide ion is a kind of ion that can donate one pair of electrons as well. Let's see another one, chloride ion. This is chloride ion which has three lone pair of electrons and another unpaired electron. So minus charge, that means another electron came from metal, like suppose sodium chloride. When it is dissolved in water, then sodium plus and chloride minus. That means sodium donated one electron to chlorine. That is why this electron is drawn here. And for this extra electron which came from metal, this minus charge is put over chlorine. So here there is actually one pair of electrons. The compounds that can donate electron pair are called Lewis bases. Now let's summarize Lewis acids and Lewis bases. Lewis acids are compounds that can accept electron pairs, and Lewis bases are the compounds that can donate electron pairs. Let's see the next point. That means Lewis acids are electronically poor or electronically deficient, and Lewis bases are electronically rich. As a result, since Lewis acids are electronically poor or electronically deficient, Lewis acids can accept electron pairs, and since Lewis bases are electronically rich, that is why Lewis bases can donate electron pairs. Or simply we can say that Lewis acids are electron pair acceptors and Lewis bases are electron pair donors. Let's see the next point. Lewis acid and Lewis base in short. Let's see a Lewis acid, boron trifluoride, and Lewis base is suppose ammonia, NH3. Here around boron there are 6 electrons, so Lewis acids are electronically deficient, and in ammonia there is one pair of electrons which is a lone pair of electrons or free pair of electrons. Here Lewis bases are electronically rich. Here Lewis bases are electron pair donors and Lewis acids are electron pair acceptors. Lewis bases are electron pair donors and Lewis acids are electron pair acceptors. Let's see the matter through some chemical reactions. Now the point is chemical reactions through which we can see Lewis acids are electron pair acceptors and Lewis bases are electron pair donors. The first reaction is between carbon dioxide and water. When carbon dioxide is added to water, then carbon dioxide acts as Lewis acid and water acts as Lewis base. Let's see. This is the structure formula of carbon dioxide. We can write in this pattern, and this is the structure formula of water. Water has two lone pairs of electrons. Here, covalently bonded electrons move towards oxygen. This also moves towards oxygen. As a result, around carbon, positivity is generated. And after that, this oxygen with its lone pair of electrons combines with this carbon, because this has lone pair of electrons and carbon is positively charged. After that, this compound is formed, that is carbon, oxygen. Here, when this oxygen combines with this carbon, then these electrons, that means lone pair of electrons, and these electrons, bond pair of electrons, there is originated electrons repulsion. As a result, these electrons turn into lone pair of electrons, that means bond pair of electrons turn into lone pair of electrons in this way. That is, here oxygen with negative charge and carbon bonds with oxygen, here hydrogen, here hydrogen. Since oxygen donates electrons to carbon, that is why a positive charge is developed over oxygen. Now, because of this positive charge, these covalently bonded electrons turn into lone pair of electrons, and this hydrogen gets freed as proton. This positively charged hydrogen ion, and this is negatively charged oxygen. So this proton combines with this oxygen, and after that this compound is formed, that is carbon with oxygen, here oxygen and this hydrogen, and this is oxygen, this hydrogen is freed, another hydrogen. So now the compound is H2CO3, H2CO3, that means this is carbonic acid. And in the formation of carbonic acid from carbon dioxide and water, carbon dioxide accepts one pair of electrons and water donates this one pair of electrons. So according to Lewis concept, carbon dioxide is a kind of Lewis acid, that means electron pair acceptor, and water is a kind of Lewis base, that means electron pair donor. Let's see another reaction. Now the reaction is between sulfur trioxide and water. Here let's write the structure formula of sulfur trioxide. This is sulfur trioxide and this is water. Here electronegativity of oxygen is higher than sulfur. That is why around sulfur there is originated a positive environment. For this reason, this oxygen of water combines with this sulfur with this lone pair of electrons in this way. Here sulfur, this is oxygen, and this oxygen becomes negatively charged. Because of this electron repulsion, these covalently bonded electrons turn into lone pair of electrons, and here oxygen and here hydrogen, this is hydrogen, it becomes negatively charged because oxygen donated electrons to sulfur. Now, because of this positive charge, this bond pair of electrons turn into lone pair of electrons, and this hydrogen gets freed as proton. This proton combines with negatively charged oxygen, and after that this compound is formed, that is sulfur with oxygen. This is oxygen, here oxygen, and here hydrogen, and another bond is here, that is oxygen and hydrogen. This oxygen, this hydrogen ion combines with this oxygen. Now this is actually H2SO4, that means sulfuric acid. So in the formation of sulfuric acid from sulfur trioxide and water, sulfur trioxide accepted one pair of electrons, so this is Lewis acid, and water donated one pair of electrons to sulfur trioxide. So electron donor is Lewis base. Here water is Lewis base and sulfur trioxide is Lewis acid. Let's see another reaction. Now the reaction is between boron trifluoride and ammonia. Boron trifluoride, this is ammonia. Now let's see the structure formula of boron trifluoride. And this is ammonia, with lone pair of electrons. Around boron there are 6 electrons. This is covalent compound. This is one covalent bond, another covalent bond, another covalent bond. So in the outermost shell of boron there are 6 electrons, which is not octet fulfilled. It has desire to another pair of electrons, and nitrogen has one pair of electrons, which is free pair of electrons. So boron try to accept one pair of electrons, and nitrogen can donate this lone pair of electrons. So here it donates electrons to boron. Now the compound is, this is boron, fluorine, fluorine, fluorine. Here the bond which is formed between boron and nitrogen is a kind of coordinate covalent bond. This is hydrogen, hydrogen, hydrogen. Now the compound is trifluoroboron ammonia or ammonia boron trifluoride. Here this is coordinate covalent bond. That means in Lewis acid base reaction a new bond is formed, that is coordinate covalent bond. The bond which is formed by the sharing of one pair of electrons, and that electrons come from one atom but share both the atoms. This is coordinate covalent bond. Here this is coordinate covalent bond. So in this reaction, that means in the formation of trifluoroboron ammonia, boron trifluoride accepted one pair of electrons and ammonia donated one pair of electrons. So electron pair acceptor is acid, Lewis acid, and electron pair donor is Lewis base. So here boron trifluoride is Lewis acid and ammonia is a kind of Lewis base. Let's see another reaction. The reaction is between copper ion and ammonia. Copper 2 plus and ammonia. When copper 2 plus is added to ammonia, then ammonia forms coordinate covalent bond with copper 2 plus. That means 4 ammonia molecules form 4 coordinate covalent bond with the copper 2 plus, giving 4 pair of electrons from 4 ammonia molecules in this way. This is copper 2 plus, ammonia, giving 1 pair of electrons. Here ammonia giving 1 pair of electrons, ammonia 1 pair of electrons, ammonia 1 pair of electrons. So in this reaction, copper 2 plus accepts 4 pairs of electrons from ammonia, and ammonia molecule each donates 1 pair of electrons. So in this reaction, copper 2 plus is a kind of Lewis acid and ammonia is a kind of Lewis base. Here copper 2 plus is electron pair acceptor and ammonia is electron pair donor, and this complex ion is formed, and the name of this complex ion is tetraamine copper 2 ion. No more today. Thank you very much.